So let's take a look at circuit protection. And we'll start off with this underhood fuse box. You'll see there's a lot of stuff going on there. And I point out a few things. One is you see that little kind of teal blue relay. This is not a relay lesson, but let's bring it out. That's probably a smart relay. Anytime you see a relay, something that form factor is probably a relay, and there's a whole, of course, lesson on relays. But you see one that's a color, typically it's a smart relay. That's what I call them. It's kind of a slang. That means it's a relay with some additional functionality, some circuitry in there, maybe it delays turning on to turn off for so many seconds after the trigger voltage shows up. But anyway, you're not going to find that. It's your typical off-the-shelf relay. That's going to be an OEM part number. I also noticed there's some blank fuses, I think, over there beside. There's like a single blue blade fuse and a whole row of empty fuses. Don't be alarmed. Sometimes you look at a fuse box assembly made for a wide range of cars, and the particular car you have doesn't have features that would use those fuses. So if you see a lot of guys, you pull the lid off and you see some fuses missing, to figure it out, and they throw fuses in there and they don't do anything because they're blank. So just because the fuse is not in the fuse box doesn't mean you've discovered the problem. So here we see a smattering of blade fuses, relays, smart relays, fuse elements. Also notice over on the far left side, that's where the power's coming in. It's a white wire on Honda. I always reference Honda because that's 20 years of my life. In most Asian cars, white is hot all the time. It's straight off the battery. So you'll see that top left corner, there's a big heavy white cable coming in, and one from the bottom. That one from the bottom, one's from the battery and one's from the alternator output, and they come together in the fuse box. And on that far left over there where they come together, you'll see a 100 amp fuse element. Just in case you disconnected the alternator wire, output wire, and you weren't smart enough to disconnect the battery first, and the wire gets away from you and it gets to ground. Hopefully it won't burn the car to the ground before that fuse element blows. Circuit protection kind of falls into three categories, three form factors, as I say. You got your standard fuses. Within fuses, you can have blade fuses, glass fuses, a lot of different. We'll look at all those. And fusible links, which just kind of become obsolete. In the early years, when you had a big, heavy current and you really didn't have a fuse to handle it, you'd put a fusible link, and we'll look at it a little deeper later on, is a special type of wire that melts into, it's a crude fuse, but it's a fusible link. And in circuit breakers, sometimes we want to embed some circuit protection into like a motor so that we don't burn a motor up, but it resets itself and doesn't blow a fuse. And now we'll look at all the fuse form factors used in the automotive industry, kind of going back from beginning to current. And one of the earlier fuses used was this GBC fuse. It's actually from European cars. I actually, as a teenager, which is a few years ago, I had a Volkswagen Beetle, and it had this fuse in it. I remember specifically these little fuses. They're ceramic with the fuse materials on the outside. It's not covered in glass or anything. Kind of an unusual concept there, but. Those have pretty much been replaced by the blade form factor, the blade fuse. Then the next iteration of the fuse was a glass fuse, a little cylindrical fuse, and this is used fairly recently. The first was the AG fuse. Research it either stood for automotive glass or all glass, but they were varied a lot, even the diameter a little bit and the length. So. I guess who knew there was a society of fuse engineers, they decided to standardize this somewhat. So the SFE fuse, which is the current cylindrical glass fuse, is a tighter standard. Basically, they're all 1/4 inch diameter, and they will vary in the length based on the capacity. You see, this goes up to 30 amps. Of course, and we've got blade fuses now that go twice that or more. So you don't see this used anymore, particularly in new cars, but it's still out there, and a lot of cars on the road are running SFE fuses. And now we get up to the current most popular fuse form factor, the blade fuse. I guess Lytle is how you pronounce it. Fuse company developed this back in 1976, and as the original blade fuse, there's like 7 or 8 variations of the blade fuse now. The first one, ATO, and it's the standard. What they've tried to do, they evolved it to make these smaller, handle more current and get smaller. So they have more circuits in a fuse box. It's not a weight factor; it's more of a just there's not so much room for a fuse box, and they can make it smaller and get more circuits in there. So I scrolled down here for you. Take a look at the. It took me a while, better part of a day, to pull them all into one chart and build you a chart here. Let's take a look at it. And here's a chart I put together that has all the blade fuse form factors across the top, and all the currents available down the left-hand side, and they pretty much have a common color scheme since day one. So this gives you all in one place, all the blade form factors. Then I'll walk through all the form factors of the blade fuses, a little bit about it. You see the dimensions. You can also download a data sheet from Lytle Fuse on each one of these blade form factors if you're really into that. Everything you ever want to know about blade fuses, I hope you'll find on this page. The next fuse form factor we look at is fuse element, and sometimes they're called a PAL, P-A-L, cartridge. They have about 4 or 5 variations. They give high capacity, I think up to 120 amps, and they also have a color coding scheme. Let me scroll down so we make sure you can see all that. Up to 140 amps. So some of them plug in, some of them have, let me scroll down to that. You'll find variations, some plug in, some are male, some are female, some have the tabs, that fold out and 2 screws go in, screws from the side. One plugs in with a latch. So there's several types of PAL fuses, but these are pretty much obsolete today, circuit breaker, because you got a PAL fuse, go over 100 amps on a single fuse. So you'll generally see a smattering, like I say, in this fuse box we saw earlier in this lesson. We saw blade fuses and PAL fuses, all in the same fuse box. Then fusible link, which is pretty much obsolete now. I don't think you've actually put it on a car in quite a while. With the evolution of the fuse industry and the ability to use like a PAL fuse or even a blade fuse to get 60, 80, 100 amps, there's no really reason to use a fusible link, which was basically it's a piece of wire. It wasn't rocket science. It's just they used a gauge of wire that would, on a given amount of current, would burn in two and open up, and then it's the same thing as blowing a fuse. And they were generally flagged, like this one's a flag on here to let you know this is a fusible link. And a lot of times you could bolt them in and bolt them out in case you had to change them. This one actually has a bolt on one end and a butt connector on the other. And another thing you can generally, if you're looking at fusible link, is the insulation is not shiny, because you've got to be careful. They have to engineer the insulation so it won't catch on fire as the conductor is melting on the inside. You don't want to, have it catch on fire and burn the car to the ground. So generally the insulation on a fusible link is kind of a chalky looking, it's not shiny. Circuit breakers are used, sometimes they have, particularly like a motor circuits, DC motor, if you put under a strain, the current ramps up real quick. And you may have temporary situations where, Uncle Bob, 350 pounds, and he's over there in the power seat, and, trying to go forward, and the car's pointing uphill. We're really putting a stress on the power seat motor, and it may momentarily really ramp up some high current. Well, if you pop the fuse, that's going to be a kind of a pain every time Uncle Bob wants to go with you somewhere. So a circuit breaker would sense that current and protect that motor by, a lot of times, a bimetallic strip. You'll see the illustration and two pieces of metal bonded together, and in this case the one on the bottom side will expand quicker than the one on the top side. So as the current goes up to get Bob's seat to go forward, it's going to heat up and rise up, and it's going to open the circuit. And then when it opens the circuit, current quits going through the bimetallic strip, and it's going to cool down and closed again, and Bob's seat works again. They tend to reset themselves, and it's just a way to not handle spikes in current when it's probably not a problem. The component's just a situation. Solid state devices, you start to see more and more of these embedded into motors, since we know electric motors and some types of electric devices that have temporary spikes in current, but you don't want to start blowing fuses and causing a lot of drama to the driver. They'll embed a PTC, solid state. It's kind of like a circuit breaker. When the current exceeds a certain amount, it's going to trip, and all the polymers, literally it stops allowing current to flow. Cools off a certain amount of time. It's like magic. It works. So you'll tend to find these are not out where you see them. They tend to be embedded like a lot of the motors, power windows, seat motors, that type of stuff would have this embedded into it. You wouldn't even see it. It may not even show up on a schematic either. It's part of the device. So you're generally not going to be dealing with seeing these and having unsoldered and putting new ones in or plugging one in. But be aware they're there and how they work. They're pretty cool. And since we're talking about fuses, you can buy aftermarket fuse holders just like this one. Use a blade fuse, different gauge wires. You can buy with more than one fuse and a block for accessories. Anytime you add something to a car, you want to come off power, the positive post, a fresh feed. Don't tap onto the existing circuit. Those are highly engineered. Extra current on there is going to cause trouble. Get your fuse holder. Might as well use a blade fuse. That's the most current form factor. And then you can tap onto the power, to the positive post. Or pull off somewhere that's clean power and go through a fuse holder like this and power up whatever you want to power up. Blade fuse on the back side is a little cutout slot there, so you can actually measure voltage on that the terminal. But sometimes the test lead almost won't go in there. So I know a lot of guys like to take a set of test leads and grind them sharper on the end, so you can really get in there easy and quick. If you use a standard set of test leads, sometimes you really got to almost force it in there to get down and touch that tab. But it's the only legit way to check for blown fuse. Sometimes you hold the blade fuse up, and you're looking through that translucent material, and it looks good. It's not good. There's a crack. Just in case that covered in the lesson just dawned on me, there's a bad history out there of cheap counterfeit blade fuses on the market. It's been a nightmare there back, 10, 15 years ago. General Motors actually issued a TSB, and it was some offshore blade fuses that were like going 2 and 3 times their rated capacity before they would actually blow, and caught several cars on fire. Don't buy a cheap knockoff fuse. You might be burn a car to the ground. And since we're talking about the fuse box, you can buy these where you can pull the fuse out, plug in a breakout loop, put the fuse back in the loop, use a nice loop to clamp on an amp clamp to measure current. It's amazing what somebody that's really into current probing and standard fuse box, and I'm just tell you, you're looking at injectors firing and fuel pump current and any other thing you want to on a multiple channel scope. It's kind of amazing, really. And we have a video there about measuring current at a fuse box using breakout loops. A little twist on this, anytime current gets through something, there's likely going to be a voltage drop. And so if you're looking for parasitic draw, which is becoming a problem now, or a challenge, the car comes in, the battery that lasts a couple of days if you don't run the car, and you find there's one of these circuits is not going to sleep, and so you got to find this parasitic draw. And so one of the quickest ways to narrow it down pretty quickly to at least a circuit is to look for parasitic draw, a circuit at the fuse box. And the concept is, and it works, I got a video here about it. Let's scroll down the video here, is that the parasitic draw, which could be milliamps, pulling going through that fuse will create a little bit of a voltage drop. It's not much. I think in this video you'll see I got 5 millivolts or something, but if there's no current, it'll be 0. So if you take it, basically you're taking and looking across for a voltage drop across the back of the fuse, and if you see anything, any reading at all, that means there's some current right there. Okay, it's a small number. You got to really, pay attention. Don't expect to be a big number, but it's, hopefully you can track it down to a particular circuit. Now then, once you get down to a particular circuit, the fuse box, now you know which trail to go down, right?